if I run this, that should be the same. Okay, so 1 and 6. And if you use the parameter axis, so we are running the same method, but here we are just passing the axis as our axis parameter, so we are saying that, okay, x is 0 and x is 1. So what does that will give us as output? So x is 0 means we want to get all the expected value for each column, so that is x is 0 each column, so I want to get the minimum value for each column. Here we should get 1, 2 and 3, right? And if you do axis 1, so you are actually trying to get the minimum value per row, so if you run x is 0, then you should have 3 values that represent the minimum for each of the 3 columns. And we have 2 rows, so if you run x is 1, then you will get the minimum values per row. That means that you will have 2 values. So for the first row, the minimum is 1, and for the second row, the minimum is 4. So that's what we should get, So we are good with that. The minimum, you run the minimum function, but you have many other functions like mean, standard deviation. The process is the same. I don't need to explain. Here we got the mean of the entire matrix. Here we got the mean of each columns, and here we got the standard deviation of each rows. Okay. So our matrix is 2 by 3 matrix. There is another important operation that we'll be doing is the reshaping of the matrix. So here you are converting from 2 by 3 matrix to 3 by 2 matrix. Earlier you had 2 rows with 3 columns. Now you have 3 rows, 2 columns. Another method that you will be using quite frequently is the flattening. So matrix dot flatten. So this is actually getting a vector. You are transforming your entire matrix to a vector. You might have any dimension matrix, but if you run this operation, that it will end up with all the values packed it into one dimensional array. Let's remove this. So flattening will give you an array, a one-dimensional array. Some other operations, matrix operation, we have already seen at the beginning of this presentation, that if you just put a transpose T, so this is another way of converting the matrix from row to column and column to row. You will need to actually do back and forth for some of the numerical operations, And you can do the dot product because you have 2 vectors, and then you take a dot product that will lead to a scalar. So here I'm not using specific vector definition, but I am reusing my matrix to define a vector. So for example, if you pay attention, then you will see that I'm referring to the first column. So all the values of the first column, all the row values of the first column. So that means one vector. So I'm actually taking a dot product of 2 columns of my matrix. And let's look at the values. This was my initial matrix. And the dot product is you multiply this guy with this guy. So 2 times 1 is 2, and then 4 times 5 matrix. And the dot product is you multiply this guy with this guy. So 2 times 1 is 2, and then 4 times 5 is 20, and you take the summation. So that's how it got 22. Likewise, you can do a summation operation. You've got just summing over all the values of column 0 and column 1. So 2 plus 1 is 3, and then 4 plus 5 is 9. So that's how the results look like if you run a addition operation. These are the several operations on matrices by using the array data structure. Now we'll be introducing you to on very important concept, what we call random numbers. At any point of your time, you will be requiring to generate some random numbers, and I can give you a few examples. For example, you want to do some development work, but the real data is not available yet. You need to generate some synthetic data because you want to progress on your tasks. Not necessarily only that, because sometimes the real data can be very costly, but so you need to have some mechanism to simulate the data, and let's say like that the data should follow some distribution. You can use this NumPy method to generate random numbers and move on with your development work. So as I said, you can run by NP random, and there is a seed parameter. So this is very important because we all want to generate our results, right? So when you initialize your seed, you will be obliged to generate the same sample over and over. That's what I'm saying. Maybe we'll give clear examples moving forward that this is one very important requirement when you report results, because let's say you have generated some results and you want to publish. So the question would be for what sample of data you used, and if I want to regenerate your result, what will be the exact sample used. So unless you do run this statement, you will be generating some samples, but you won't be able to track what samples you used for your experiment. Okay. So here I'm generating 3 floating point random numbers between 0 and 1, and you can see the numbers. And here I'm doing the same, but I'm generating a math. Here I generated 3 undimensional data points, and here we generated 3 data points, 3 values. That means that 3 rows and 3 columns, So this is a matrix representation of some random data. So these were floating point numbers. Here we can generate integer numbers, So for example, here we are generating 3 values between 0 and 10. So you can see that 3 values between 0 and 10. And you will require that. Like for example, you want to sample discrete data. There you will require that what index I am hitting, You will have some better examples, but this is how we are generating random integer data. Likewise, here we are generating 3 data points from a normal distribution with the mean 0 and standard deviation 1, So you can see. You can generate any number of data points that you will require. And some of our projects or maybe class assignments will be looking at how we are generating synthetic data using this random number generator for us, I am going to show you. So for example, np random dot, if you put the dot and see like what are the different methods available. So you can see that you have exponential distribution, gamma distribution, and then you will have logistic. A lot of distributions have been implemented, and you can generate random data from those distributions. You will find most of the important distributions, although not all, This is all about this presentation. So if we summarize, we were introducing NumPy. We are introducing NumPy array and how to use NumPy array as vector and matrix. And we were showing how some operations like mean, standard deviation, average, max, mean, you can go on and on, how to manipulate your data. And we also covered how to sample data given that you provide some parameters of your own, because that is a very important part of our data processing activities, So we'll be discussing more moving forward. I will be in this notebook on my GitHub and sharing with you guys the link so you can play with the notebook and ask me if you have any questions. Thank you so much.